Good morning, everyone. Hope all is well. Hope everyone is doing all right. Everybody is in.
Good morning.
Hey, how's it going?
Good. How are you?
I'm good. A little tired, but that comes along with the 8 o'clock class.
I know I just woke up. I'm not gonna lie.
Oh man. All right, looks like everybody's in. Got a few coming in, but it's all good. So before we get rolling, any questions, concerns, comments? Everybody good, straight? All right. All right, silence is golden. So let's look at this next section that we're talking about today. Oh no. So we did 3.5 last class. So we'll look at 3.6 today. Polynomial and rational inequalities. So of course we have polynomial rational equations. This time we have our inequalities. Excuse me. So first one, or the first type we'll look at is a quadratic inequality, and that'll really set us up for the rest of the problems. If you look at our first, diagram right here, this parabola, concave up, we talked about that before. Notice how it responds only one of two ways. From negative infinity to infinity, it's a negative infinity to this point right here. It's above the x-axis, so it's positive. From this point to this point, it's below the x-axis, so it's negative. And then from this point to infinity, it's above the x-axis, it's positive. So the way the graph is behaving is positive, negative, positive. And then here, if it's concave down, notice it's negative down here, positive up here, and then negative down here. So it alternates. And we'll have negative, positive, negative. So like I said, that's going to set us up for the thought process of moving forward and how this graph behaves as it goes from left to right. You get positive values here, and then negative values down here. But here's negative, positive, negative. So they alternate. And notice what changes or what dictates, when it alternates is those points on the x-axis. So remember, and then over here, I was just saying that, these are inequalities, just reminding you less than, greater than equal to, less than equal to are our inequalities that we will be using. So we have 2x squared plus x is greater than 15. Notice the first thing I said is that we want to set one side equal to 0. So subtracting 15 from both sides gives us 2x squared plus x minus 15 greater than 0. All right. So if we want to know when is 2x squared plus x minus 15 greater than 0, in other words, we're saying when is this expression positive? So if something is greater than 0, that means it is positive. So we want to know when is it positive. So now we want to set it equal to 0 and solve. Remember, we said that there was 2 points that we want to know. So we want to set it equal to 0 in order to figure out where those 2 points are. So set it equal to 0. And we get those two values. Any problems? So first we made sure one side was equal to 0. And then we set it equal to 0 so that we can solve for those values, or when the expression is equal to 0. We're going to come back to the greater than sign. But right now we just want to know what two values has my equation equal to 0. So here, just using the generic number line to establish what's going on, we have -3 and 5/2 as these points where our equation is equal to 0. And then you notice that it will set up these intervals: -∞ to -3, -3 to 5/2, and then 5/2 to infinity. All right. Any questions so far? All right. So the next step is to go ahead and set up this type of chart. Now you don't necessarily have to make a chart, but it'll be best for you to make a chart to keep everything organized, and you'll be able to easily see your answer once you fill it in the chart. But some people choose not to, and that's fine. But notice that over here in this column, we have our interval, test value, and behavior. So those are the three categories that we're looking for. Our interval is set up by this and our values. So notice the first interval, like I mentioned, is -∞ to -3, -3 to 5/2, 5/2 to infinity. So now we need our parentheses or brackets accordingly. But don't forget, infinity signs will always have parentheses. Then you go back to your problem. We have the greater than sign. Remember, greater than sign will always have infinity parentheses as well. So we should use, I don't want to use purple. We should use parentheses on all of them. Remember, when you have the or equal to symbol under it, that's when we're looking to use brackets. All right, questions on that top row. All right. Now we need a test value. Remember, we talked about initially that everything from this point, from infinity to this point, will respond a certain way or behave a certain way. Everything in this interval will behave the same way, and everything in this interval will behave the same way, whether it's positive or negative. All of those values will give you, within that interval will give you the same type of result. So what you need to do is just pick a value in that interval. You don't have to choose anything crazy. When you look at this first interval, anything less than -3 will work. So you could go -100 if you want to. Just remember that whatever you choose, you're going to have to calculate with it. So something easy like -4 will work. That's less than -3. Something between -3 and 5/2. So if I can choose 0, I'm always going to choose 0. Then something greater than 5/2. So it's 2.5. So I think I chose 4 originally. But it doesn't matter. Anything greater than 5/2 will work. But you have to make sure that the values you choose are in those intervals, or things won't work out right. All right. Questions on our test values? All right, once you've established some test values, you're going to plug your test values into your expression. I normally just use the factored version of it because you can get out a number. I really don't need the number. All I need to know, is it positive or is it negative? Because if when I plug this value into the expression and I get out a positive value, that means all the values in that interval will be positive. So generically, if you look at the first one of what I did, I plugged -4 in here. And the result in that first parentheses will be negative. Result out of the second parentheses would be negative. Multiply those together, I'm going to get a positive value. And that's all I needed, and that's all I wanted. Now, you want to do the work. 2 times -4 is -8. -8 times, or not -8, -8 minus 5 is -13. Then -4 plus 1 is -1. So you're talking about -13 times -1. That'll give you a positive 13. That's fine. But all I really need to know is it positive? Okay. And I put that right there if you want to see it. That's -13, -1. Do the same thing for 0. I'll get a negative value times a positive value, which is negative. Plug it in +4. I get a positive result. Before we go any further, any questions? All right. So now to figure out what our answer is, we go back to our original problem. Now I'm scroll back down, of course, but we want to know, when is it positive? We have greater than 0. So when is it positive? So we go back to our chart. It is positive here and here. So that represent those top intervals of -infinity to -3, 5/2 to infinity. And so that's our answer. If it was less than, or if it said less than 0, then we would have chose that middle interval, and that would have been our only answer. Any questions? Any questions?
So for the when we're figuring out if it needs to be positive or negative, for the one where you plug in 0, you just get 0.
No, if you were to plug in 0 right here, notice -2 times 0, 0 plus 1, that'll be plus -5 would be a -5 right here. And then here.
Oh, because you're timing 0. Yeah, never mind. Sorry. I was doing -3 plus 3.
Okay, not a problem. So yeah. All right. Anybody else before we go to the next one? And so this is the foundation of what we're going to do with all these problems. Set one side equal to 0. Solve it for when it is equal to 0 to set up your intervals. Get your test values for each one of your intervals. Plug them in, and then see when it's positive or negative. And then according to what your answer is, that's what your original problem is. That's what your answer will be. All right, can you scroll up to the next one? All right, so let's do it again. This time we have a cubic equation, x cubed plus x squared less than or equal to 4x plus 4. And just like before, we want to set one side equal to 0. So I minus 4x and minus 4 from both sides. Okay. All right, so now we have x cubed plus x squared minus 4x minus 4 less than or equal to 0. So you see that red circle. Now, since it's less than, we want to know when is it negative. Remember before it's greater than 0, so we're talking about positive result. This time it's less than 0, so we want to know when is it negative. We want to know when are we getting the negative result. So just like before, set it equal to 0 and then solve. So we have x cubed plus x squared minus 4x minus 4 equal to 0. We have 4 terms here. So we want to factor by grouping. Group together the first 2 and second 2. In the first one, I factored out x squared. Second one, I factored out negative 4. X squared plus x squared times x plus 1 plus negative 4 times x plus 1. X plus 1 is in common, bring that out front. X squared minus 4 is left in the parentheses. X squared minus 4 is a difference of squares, so that'll be x plus 2, x minus 2. Set each one equal to 0 and solve. And there are our 3 solutions. Now, if our equation was equal to 0, then we would stop right there. But of course, we want to know when is our equation less than or equal to 0. So we have to keep going, following the process that we did in that first. All right, can I scroll up? Okay, so just like before, generically that sets up our intervals right here. I'll just give you a visual as to how this thing will go and how our chart will be set up. If I can put those back. All right, so that first interval is negative infinity to negative 2. Then we're talking about negative 2 to negative 1, negative 1 to 2, and then 2 to infinity. So that's what we have right here. Now you want to set up your parentheses and brackets. Parentheses on each infinity sign, that will always be the case. And then if you go back, remember we have or equal to. So that's why I'm going to use brackets on my numbers. So I chose those test values, -3 because it's less than -2. We have -2, -1. So I need to choose something in between -2 and -1. So -1.5. Then something in between -1 and 2, that's 0. And something greater than 2 is 3. Once again, you can choose anything in those intervals. Just have to make sure the values you choose are actually in those intervals, and you'll be all right. Any problems? Good. So now we can plug them in. And just like before, I use my factor representation of that equation or expression and just plug them in to see what I get. -3, when you plug it in, you'll get negative times negative times negative, which will give you a negative. Plugging in -1.5. Negative plus negative, negative times positive times negative will give you a positive. Now then, I don't know if I mentioned earlier, but if you want it, you could always use this too. That's the same thing. It's just up to you how you want to do it. Like I said, I do a lot of things by hand on the board, so try to go the easiest route possible. Plug it in 0, plus plus minus, gives you a minus negative result. And then last one, plugging in +3, gives you a positive. All right. So once you've done this and you have your chart filled out, remember you go back to the original problem. We were dealing with less than. We want to know when is it less than 0, which is negative. So both of these pieces would be where our answer would lie. And so that's how we got our answer right there. All right. Questions? Any questions? Let's scroll up. All right, the next type of problem, rational inequalities. So going back to those fractional setup for us. X plus 3 over x minus 7 is less than 0. So we're going to set our numerator and our denominator equal to 0 to establish our intervals. You know, before we just factored and got our pieces through our factorizations. This time we'll set our numerator and our denominator equal to 0. So x plus 3 equal to 0 gives you -3, x minus 7 equal to 0 gives you a positive 7. So right here helps us set up our interval. We have a less than symbol, so we use a parentheses for all. So we got negative infinity to -3, -3 to 7, 7 to infinity, and use a parentheses on each. See the test values I chose, -4, 0, and 8. Something less than -3, something in between -3, 7, and then something greater than 7. I'll just go ahead and leave that in there. Now let's see how we got those values. Scroll up. So this was our expression, x plus 3 over x minus 7. So you plug in those test values accordingly. So once again, I just want to know what the signs are. So -4 plus 3 over -4 minus 7 gives me a negative over negative. That's going to be positive. So that's how I got that first behavior. Plug in 0, gives me a positive over negative. So that's that right there. And then plugging in 8 gives me positive over positive. Just give me a positive result. All right, any problems, or questions? All right, so our middle column gave us the less than. That corresponded to the interval of -3, 7. So that's why our answer is -3 to 7. Any questions? Any questions? Can we scroll up? Anybody still copying? All right, so Next one, we have x plus 1 over x plus 3 greater than or equal to 2. So just like before, you want to set one side equal to 0. So we're going to minus 2 from both sides. All right, so got to be careful here. Don't forget we have rational expressions, or in other words, fractions involved. So minusing 2 from both sides is more involved. We have to have common denominators. So that 2 is going to be 2 over 1. We have a denominator of x plus 3. So I'll multiply both top and bottom by x plus 3. So I can have that 2 with a common denominator. So that's that right there. So I'll bring them together here without doing any distribution, because I want to make sure that we hold true to this minus sign right here. That minus sign needs to be distributed into that parentheses as well. So be careful with that. A lot of times people make a mistake and they only give that minus sign to the first term, but that minus sign has to be distributed into the parentheses that follows, or into the term that had, that numerator that follows. So distributing, that'll be x plus 1 minus 2x minus 6 in the numerator. Combine your like terms. This is the result. So we have negative 5 minus 5, negative x minus 5 over x plus 3. And we have, when we put it back into our problem, minus x, or negative x minus 5 over x plus 3 greater than or equal to 0. So that's our new problem that we're trying to find or solve. Any questions before we move further? All right, scrolling up. All right, got a few notes going on here. So just like before, we're going to set numerator and denominator equal to 0. That gives us negative 5 coming out of the numerator and negative 3 coming out of the denominator. All these notes are going to make sense in a second, but I was going to erase it, but I was just like, I'm going to put it back anyway. So I'll talk about all of these notes in a second. All these circles and arrows. All right, so the numerator gives us negative 5. Denominator gives us negative 3. So when we talk about interval setting up, interval gets set up for us. We got that negative infinity to negative 5, negative 5 to negative 3, then negative 3 to infinity. All right. So before we go any further, is everybody okay with that top row? Having our intervals. All right, so now we need to establish what gets parentheses, and then what get bracket, if anything get bracket. So we know all the time, every single time that we deal with this, infinity signs will always get parentheses. That never changes. Now we notice that we have a or equal to here, so that means we're going to use a bracket somewhere. So in this case, because we have a fraction, remember our denominator cannot be equal to 0. But if I were to plug in this negative 3 into this expression, that will give me 0 in my denominator. So I cannot use -3. -3 helps us to set up our interval, but I cannot use -3 because it makes our denominator 0. So, and remember, bracket always means that you can use it as a part of your solution set. So what this means is that we would do bracket on the -5, because that comes out of our numerator. But then we will use parentheses on that -3, which comes out of the denominator. Before, we didn't have to worry about it because we didn't have the or equal to sign, so everything was parentheses. But because we have brackets here, I'm talking about in the last problem. When I say before, in the last problem, we didn't have to worry about it because everything was parentheses. But in this one, because it says or equal to, we do have to consider the fact that we cannot put a bracket on that -3. Whatever value comes out of your denominator, you cannot use a bracket on. All right. Questions on that? Questions on anything that I said about this interval? These intervals. All right. So choose your values, your test values, -6, -4, and then 0 is what I chose. Something less than -5, something in between -5 and -3, and then something greater than -3. Remember, I always try to use 0 if I can. One of the easiest values to calculate with. So we're going to use our most simplified expression, which is -x minus 5 or x plus 3. Of course, let me know if I scroll up too far. I want this down here. So plugging in -6 gives us a negative result. Plugging in -4 ends up giving us a positive result. Plugging in 0 gives us a negative result. So notice each one of our outcomes, going all the way to the beginning of this section, alternated in signs. But you cannot lean on that thought process every single time, especially if you were to go into calculus. It's not always going to alternate like that. So you do want to make sure that you hold true to the process. And then sometimes, especially if you're leaning on the fact that it's going to alternate, if you were to mess up on the first calculation, then you alternate, that means you're going to get the rest of them wrong. So you do want to make sure you walk yourself through the process and make sure you have the right answers. Okay, that's good. Yep. So we want to know when it's going to be greater than or equal to 0. Yep. So that we choose the positive one, which was the one in the middle, -5 to -infinity. I mean, -5 to -3, excuse me. Bracket on the 5, parentheses on the 3, and that would be your answer. Questions, questions, questions. All right. Can I move off this page? Everybody good? Everybody still copy? All right. 7. Okay. So we have one more section for chapter 3. So I'm going to pause right here. And I'm trying to give room for some people to get caught up. So I'm going to pause right here. Did anybody have any questions on anything before we close out today? Everybody good? Everybody straight? Okay. As always, try the stuff out. See if you get stuck. If you have any questions, make sure you bring them to class so we can, walk you through it. Make sure you're good to go. If you guys are good, I'm good. Have a great weekend. Be safe, and I will see you on Monday. Looking to close out chapter 3.
Thank you. You too.
Thanks. Take care.
Thank you. Have a good weekend.
Have a good
Thanks.
weekend.
You the same.
Expecting. Have a great day.
Thanks. Take care.
Bye. Have a good day.
Thank you. Take care. Have a good one.